This is practice problem 9.3, complex number, basically just practicing with complex numbers. And there's two parts to it, A and B. So we'll go through and do each one of those. I'll switch over to the document camera here. All right, so we're going to evaluate these numbers, and we're going to start with A first. Let me just rewrite it down here, and I'm going to take the 5 plus j2 times the minus 1 plus j4. We've got this, and we've got minus 5 angle 60 degrees. Oh yeah, and this is the complex conjugate, so that's the asterisk there. So what we're going to do, I'm just going to look at this part first. And I can just go ahead and multiply and distribute things. So I'm going to have minus 5 minus j2 and then plus 20j, right, from these two, and then plus, oh, I put the j. You're supposed to write it with a j out front. Well, it doesn't matter, but j squared 8. Remember, j squared is just, well, j is just square root of minus 1, so this becomes a minus 8. Right, so I've got a minus 5 and a minus 8. That gives me a minus 13. And then I've got it's supposed to be a 2. It's not a squared. I've got 2j and 20j. This is a minus, so I've got plus 18j. That's that. And then this over here, what does this become? Well, remember we said addition and subtraction are easier when you're in the rectangular form instead of polar. So I'm going to convert this into rectangular, and I'll just draw this out for you so you can see where these numbers are coming from. This is basically 5 at 60 degrees, right? So it's got an x component and a y component. And, you know, this is just, let's see, what are we going to get? We're going to get 60 degrees, so we have x is 2.5, right? This is just 5 cosine, sorry, yeah, 5 cosine 60, 5 cosine 60, which is 2.5, and then you have plus, you've got j, and the y component is just 5 sine 60, which is going to be 4.33. So that's where that's coming from. Let's see, so now we're going to put this all together, and we've got this, and we have minus 13 plus j18 minus 2.5 plus j4.33 complex conjugate. These things, again, we're just adding like terms. Well, yeah, we got a minus 13 and a minus 2.5, so we get minus 15.5 plus, and then we've got, a minus 4.3, so we got a 13.67. Oh, this is a j. And then we've got the complex conjugate, which is just negating our j, right? So this equals minus 15.5 minus j 13.67, right? The other way you can write this, right, or you can write this as, if we look at the way this goes, we've got a minus 15.5 and a, that's a plus. Oh yeah, this is a minus. So I'm looking at the plus here. This is a minus. Then we've got a minus 13.67. So we have an R like this. This just turns out to be 20.67 from Pythagorean theorem. And then you have an angle, let's see, This is theta. Let's call this theta. And phi is just theta plus 180. This is going to be, so phi is just inverse tangent of 13.67 over 15.5. Oh, sorry, that's not phi, this is theta. That's theta in here. Phi is theta plus 180. What does this equal? Oh, you know what? I just did the, I didn't actually calculate that number. I just added it to the 180. Inverse tangent of 13.67 divided by 15.5 gives you, oh, the wrong number. Let me pause this. 41.4 degrees. So then phi is going to be this plus 180. So you're going to have 20.67 at an angle of 221.4 degrees. So these are the two different ways you can write the answer. Now you can also write this less than 180, but it's going to be in the opposite direction, right? So it's just let's say 221.4 minus 360. Yeah, it's going to be the minus 138. 41.4. Yeah. So this is, you can also write this as 20.67 angle minus 138.6. Right? Because that goes the same. It goes the same way. Oh. On a graph, right? The polar coordinates this way, 221.4 is equal to this way, minus 138.6. So that's all we're doing when we do that. Okay, oh, part B, yeah, that would be helpful. I'm going to adjust my camera here for a minute. All right, back with part B. Yeah, so part B, this is a kind of a monster of an equation, right? We've got 10 plus J5 plus 3 angle 40 over minus 3 plus J4 plus 10 angle 30 plus J5. So lots of stuff going on here. Let's convert a few of these things over. Let's see, I'm going to call this A. I call this B. This will be C. And then we'll have D and E. So let's look at B first. This is already in, so remember, addition is typically better done in rectangular coordinates. So I'm going to convert this, I'm going to convert B to rectangular. 3 angle 40, right, is basically, you know, looks like this. It looks like 3 at an angle of 40 degrees, right? So this is, all this is going to be is, for the x component, we're going to have 3 cosine 40. So we've got 2.298 plus j is going to be 3 sine 40, right? So we've got 1.1928. And then I'm going to take this over here. I'm going to add it to the 10 plus J5 plus 2. Oh, let me, so this is C, sorry, B, do plus B, equals, so now I've got the 2.298 plus 10, I've got 12.298, then I've got a plus J, 6.928. Oops, did I mess up the, yeah, this is This is supposed to be 1.928, not 1.1. This is 1.928. So this is 6.928. So this over here is A plus B. This is the top part. Let's see, what do we have? Oh, right. So now we have, for division, right, it's better if we work in polar coordinates. So now we've got to divide A plus B by C. So how are we going to convert those? Well, this is just going to convert into, let's see, R and theta. And here we've got 12.298. Here we have 6.928. A plus B is going to go to what? It's going to go to, if we take square root of this squared plus this squared, we get 14.115 angle 29.39 degrees. This is A plus B. And again, that's just from doing, what is it doing? It's taking the, well, it's going backwards, right? It's taking the individual vectors and summing them to get the R vector with theta, or use Pythagorean theorem for R, and you just use the tangent relationship for theta. So that's what you get. C is going to look like this. C is a minus 3 plus J4, right? And this is going to equal, let me leave myself some room here, minus 3 plus 4. This is your vector R. This is your theta. Right, it's a 3, 4, 5 triangle. So we've got 5. Oh, yeah, that's 5. Because that's just an R value. It's not positive or negative in this case. And then our angle is, we've got this angle, but we've got to add it to 90 degrees, right? So, oh, not 90. We've got to add it to, well, yeah, we've got to add it. Let's do the math here. We got to subtract it from 180. This angle, theta, is inverse tangent, right, of 4 over 3. And this gives you, where did I write this? Apparently nowhere. So that gives you 53.13 degrees. To get the angle phi right here, phi is just 180 minus theta, right, which gives you 126.87. So that's our angle here, 126.87 degrees. So that's C. So now let's look at A plus B over C. And that is going to be, we've got 14.115 angle 29.39 degrees over 5 angle 126.87 degrees. So remember, with division, you divide the R's. So we're going to have here 2.823. And then you take the difference between the angles. But it's top minus bottom. So it's 29.39 minus the 126.87. We get minus 97.48 degrees. All right, now what do we got to do? We got to add this to all this stuff. It probably makes sense again to go into rectangular. So this is just going to convert into Should I draw it out? Let's see. This is going to be minus 0.3675 minus J 2.799. All this is, right, it's just a vector with length 2.823 at minus 97.48. So it looks kind of like this. So you can see you can have a negative. Oh, geez, I drew it the wrong way. It's minus. So it's going to be this way. Minus 97.48. So you can see it's going to have a minus J component and a minus real component. And again, this is just trigonometry. All right, so we switch that back to regular notation. So what do we have? We have D. Oh yeah, D's got to be converted. D is 10 angle 30. 10 angle 30 degrees. So that is going to be equal to, again, I'll sketch this out, right? We've got 10 at an angle of 30. We've got 10 cosine 30, so that turns into 8.66 plus, we got 10 sine 30 for the J component. We've got 5 there. Right. So now we have the full equation. What do we have? This is, so A plus B over C is this minus 0, I should write this out. So A plus B over C plus D plus E. This is going to be equal to minus 0.3675. Can you guys tell I'm trying to stay on one sheet of paper here? Minus J 2.799. If I run out of paper, I'm confined to my house. I can't get any. I have to use toilet paper. What am I doing? Plus 8.66 plus J 5. Right, so this is A plus B over C. Right, this is D. And then E is another J5 plus J5. So here we just lump terms, and we've got 10J minus 2.799. I'm going to round that, so we've got, let me do the front number first. 8.66 minus that, we get 8.2925 plus J 7.2. This is our answer for part B. Now you can also write this, again, as an angle, or, right, what do we have? We have 8.2925 in the x direction and a minus 7.2 in the j direction. Oh, wait, it's a minus or a plus? I think I messed up the sign here. Hold on. Let me check. Oh, I don't know. My notes said minus, but it's actually a plus. And I wrote a plus, so I don't know. I'm losing it. All right, so we have 8.2925, and then we've got 7.2. So here we have our R, and here we have our phi or our theta. So R is just going to be, right, this squared plus, well, the square root of this plus this squared. So we're going to have 10.98 with an angle of And again, the inverse tangent of 7.2 over 8.2925 is going to give us an angle of about 41 degrees. So this is the answer for part B. Yeah, I know that was really exciting. I think you guys are really enjoying this. I wish I could see your faces. Okay, have a good one.